Hello, thank you for joining me once again on Obasic Academy. On today's tutorial, I shall be looking at how to estimate dynamic ordinary least square using EViews. Essentially, how to estimate DOLS using EViews. As a means of introduction, we'll have the Dynamic OLS was introduced by Saikonen in 1992 and Stock and Watson in 1993. The DOLS is simply a technique that addresses the problem of homogeneity by including the leads and the lags of phase difference exogenous regressors. The lags deal with autocorrelation and the leads are there to address homogeneity that emanates from the feedback effect. Now the question is, why is DOLS superior to OLS? Dynamic ordinary least square is robust to homogeneity and does not require the use of instruments like the two-stage least squares or instrumental variable approach. There is no theoretical basis for choosing the number of leads and lags. However, some scholars use the general to specific approach in which they include a lots of leads and lags and they try to trim down by removing insignificant lags until they come to a point where the model is perceived to be parsimonious and has relevant leads and lags. DOLS is equally applicable in small or large sample sizes and it is robust to the problem of autocorrelation. That is, it deals with autocorrelation using the feasible GLS procedures. It deals adequately with the problem of feedback effects. As we know, heterogeneity might arise from a case where there is a feedback effect coming from the dependent variable to the independent variable, that is y to x, which could bias the parameter coefficient, which is beta, apart from the correlation between the error term u and the independent variable. Endogeneity can of course come from different means. Okay, DOLS is a co-integrating estimator, and as such, if you have a combination of non-stationary variables that are possibly co-integrated, you can apply DOLS. DOLS can also be applied if your regressors have a mixture of I1 and I0. That means you can apply DOLS if you have variables that are integrated of phase difference and of order 0. Now the model specification for DOLS according to Stock and Watson is captured here in equation 1. As you can see here, we'll have it here specified. Then under the assumption that the Q lags, okay, and the R leads of the difference regressor soaks up all the long run correlation between the error terms. If, for example, we want to formulate the above model, that is this equation 1 here, using one lead and one lag, we'll have this specification captured here in equation 2, as you can see here. The long run or co-integrating coefficient or vector, that is B1, which is this particular B1 here, is what the researcher should focus on, while the different leads and lags, which are B2, B3, and B4, are usually not interpreted in a DOLS estimation technique. And this is because Stock and Watson 1993 considered the different leads and lags as nuisance parameters, as their role is meant to address feedback effect and autocorrelation. Meaning after estimating this particular model for here, like this equation 2 we have here, you don't need to interpret the parameter B2, B3, B4 here. Okay, they are considered as nuisance parameters. Really concentrate on the long run coefficient vector here, which is this B1. Okay, so with this brief introduction, we'll move straight to EViews, where I'm going to show you how to estimate it using EViews. Okay, coming down to EViews here, we'll have our variables already captured from 1985 to 2021, looking at 37 observations. BMS here stands for broad money supply, GDP here stands for gross domestic product, and INF here stands for inflation rate. Okay, remember you need to check the univariate integration properties of these variables before you can use them for DOLS estimation. That means you need to conduct unit truth test on each one of them and they should be possibly co-integrated also. And remember you can use them if all your variables are integrated of order 1 or true, or if they're a mixture of order 1 and order 0. So estimating this model here, our GDP is the dependent variable, the BMS and INF are the two independent variables. Now there are two methods or two ways via which you can actually estimate DOLS using EViews: the inbuilt approach and the manual approach. So I'm going to show you the both of them, but we'll start with the inbuilt approach first. Okay, for us to estimate this model using DOLS, estimate these variables here using DOLS, what I need to do is to come to quick. That's, we want to start with the inbuilt approach now. Estimate equation. Okay, our dependent variable is GDP space C space BMS space INF, which are the two independent variables we'll have here. Okay, then simply come down to this method here, click the drop down button and select co-integrating regression. All right, then come down to this method here and change this fully modified OLS by clicking the drop down button and select dynamic ordinary least square, which is DOLS. Alright, as soon as you select it, you discover that we'll have other boxes captured here, the fixed, lags 1 and leads. So these are what defines the dynamic OLS in this particular specification, as you can see here. Now looking at this fixed here, fixed is if you want to specify your own lags by yourself, you simply select fixed and choose the lags you want, maybe the lags and the leads you want, or you simply adopt the archaic information criteria or swatch information criteria, any of the last selection criteria of your choice, and use. Let's take for example, we want archaic information criteria to select the lags for us, the leads and the lags for us. If you select archaic information criteria and here you may have to specify the maximum lags. Let's assume the maximum lags is 5. What it simply means is that from lag 1 to lag 5, we are simply instructing archaic information criteria to select the optimal lag from lag 1 to lag 5. You cannot select lag 6 because you've already given it a maximum of lag 5 to choose from, or to give you the best model from lag 1 to lag 5. Okay, however, I need to specify that there's no theoretical basis for choosing any particular lags. Okay, you can as well choose the lag of your choice. In this case, I'll allow it to be on fixed so that I can be able to select the leads and the lags of my choice. Okay, here I'll select 2 lags using this specification, and I'll also select 2 leads. Okay, what I also discover using this particular method is that the higher the lags you choose, the higher the chances of your model evading serial correlation. Okay, so I'll leave it on 2 lags and 2 leads. All right. Okay, then the next thing I'll do is to simply click OK. Now once you click OK, you have your result here. As you can see, the dependent variable here is GDP, the method here is DOLS. I will have our variables, so I have the coefficient captured here, the R squared. But then if you look at this result here, you discover that there are some indicators here that are missing, or some components here that are actually missing, like the F statistics is not captured here using this inbuilt method. However, I will show you how to estimate that F statistic or generate it from this particular result here. But there's something else I want to show you here that makes this particular inbuilt method to have some limitations. For instance, if you want to check the diagnostic text by clicking View, then select Residual Diagnostic, you can see here you cannot be able to check the heteroscedasticity, the Q-sum test, the Ramsey reset test. However, you can only check the normality test and covariance Q statistics. So let's also want to check the normality test here. By clicking this, you have your normality result, as you can see here. Okay, this is the normality result. So I'm going to copy it out. So by the time we are running the manual approach, we'll compare the result generated. So I'll copy this normality result, and I'm going to paste it here. Okay, let me paste it here. All right, let's go back to the EViews. Go back to the main result. So I also copy out this main result so that by the time I estimate the manual approach method, will compare the results also. So I'm going to copy this out, and maybe I'll paste it at the top here. So I pasted it here. All right, so looking at this result here, you have the R squared, the adjusted R squared, your coefficient, and your T statistic, but we don't have the F statistic here, which captures the overall significance of the model. As you can see, the BMS and the INF are all significant at least 5%. As you can see here, even 1% even, because they are all greater than 0. They are all less than 0.01, as you can see, basically. So they are all significant at 1% thereabout. So you can see the R squared value and the adjusted R squared. So for us to get the F statistic, which captures the overall significance of the model, what we need to do is to simply click View. Okay, then select coefficient diagnostics, then wild test coefficient restriction. Now this box appears here. If you look here, we'll discover that here we have coefficient for BMS, INF, and C. So this is C1. The first, going by how it is serially arranged, this is C1, coefficient 1, coefficient 2, and the constant is coefficient 3. So we are interested in looking at the F statistic, which captures the joint significance of the variables, which are the independent variables here. So we'll simply rely on C1 and C2, that's coefficient 1 and coefficient 2. So what I need to do is to come to this box here and type in C, open bracket, 1 equals to C again, open bracket, 2. So that we can be able to get our F statistic, which measures the overall significance of the model, and set it equal to 0. So this C1 and C2 are simply this C1 and C2. As you can see here, C1 and C2. Then simply click OK. So once you click OK, you have your while test. This gives us the F statistic for the overall significance of the model. Okay, this is the F statistic. So you can as well copy this and add it to your result of the dynamic ordinary least square if you use the inbuilt approach or inbuilt method. All right, so then the next thing I'm going to be doing is that I'm going to estimate it using the manual approach, so I can be able to see how the result will look like. I will compare to see if we get the same result. So what we need to do is to go back to estimate, all right, and change back this to least square. We'll select the least square method. Okay, I've already typed out the specification so that I don't waste your time watching this video. So we'll have it here. Look at the specification here. We'll have GDP, broad money supply, INF, the difference of BMS, which is the broad money supply, the lead of the different lead 1 of BMS, the different lead 2 of BMS, and we'll have the lag. We'll have the second lag. Then we'll have for the second variable inflation, we'll have the lead. We'll have the second lead. Remember, we'll use 2 leads and 2 lags, so that's why I'm maintaining the 2 leads and 2 lags here when we estimated the earlier one we had, as you can see here. Okay, so what I need to do is to copy this, all right, and go back to EViews. Already we have some of them specified there, but I'm going to wipe them off so that we can have one complete set of model, as you can see here. All right, so this is how to specify it. You have to specify it like this in your equation box here neatly. So we're going to estimate this particular specification using the least square, but the outcome will give us the dynamic ordinary least square, given that the specification we use is the dynamic least square specification, as you can see here. So simply click OK. So once you click OK, we'll have our result. As you can see, we're only interested in these 2 rows here, which are the cointegrating vectors or the cointegrating coefficients here. Remember, Stock and Watson considered all these as nuisance parameters, and that's the reason why I didn't see them in the inbuilt format. Okay, what the EViews did was to estimate this model without presenting this result, this first difference result here, both the leads and the lag, because they are considered as nuisance parameters. Their job here is just to correct endogeneity problem emanating from the feedback defect and the serial correlation, as you can see here. So what I'm going to do is that I'm going to copy this out. I will compare it with the one we captured from the inbuilt method to see whether we'll have the same result. Okay, yes, so this is the one we'll copy there. Let me push this down so that we can paste this somewhere here so I can be able to compare. All right, so we have the result. Now if you look at this result here, I'll have the coefficients here. They are approximately similar to each other. As you can see here, BMS is 0.249, we'll have it here. INF is minus 0.215, as you can see. But then if you look at the probability values, they are still statistically significant even at 1%, though they might not be exact the same, but they are nearly similar to each other, as you can see. Now look at the R squared, okay, for the inbuilt result. As you can see, 0.6655, and the adjusted R squared is 0.4542 here. As you can see, they are the same. Can you see that? So the results are approximately the same using the inbuilt format and as well as the manual approach. The only challenge is you being able to specify the model correctly without having any mistakes in terms of putting the bracket sign, the leads and the lags according to how you want it specified. So I can see the results here are practically the same using the inbuilt approach and the manual approach, but the manual approach has some advantages over the inbuilt approach. From this result now, we can be able to estimate our heteroscedasticity, the Kusum test, and the rest. We can as well view that by clicking view residual diagnostics. As you can see, we can conduct our serial LM test. Normally, let's start with the normality test so that I'll compare it to the earlier one. Okay, let's copy it. Look at the value here, 0.79504. So let's compare it with this. That's the inbuilt results. Let's see. So I'm going to paste from the manual approach so that we'll see whether I will have the same results. Taking some seconds to come up. Yes, it's here. Now look at it here. Look at the inbuilt result, 0.45. As you can see, Jacobera. So they are basically the same. As you can see, they are basically the same. Okay, we can also conduct our serial correlation test neatly. Okay, so simply click OK. As you can see here, there is no evidence of serial correlation, but this is greater than 0.05 or even 0.01. As you can see, you can as well conduct your heteroceracity test using the Bruce-Bogan-Guthrie test. Can you see that? All of these were not possible using the inbuilt format or approach, as you can see. Then we can as well conduct our recursive estimates. That's a Kusum test for stability. As you can see, the model is stable because it's within the critical boundaries. Then you can as well conduct the Kusum square test. Okay, so the two formats are actually the same, but just that using the manual approach, you can be able to estimate other post-estimation diagnostic tests. So when presenting or discussing your results, the only thing you need to interpret is this the long run coefficient here, the long run co-integrating vector here. That's what you need to interpret. Whereas all these are considered as nuisance parameters. Their function is just to correct the endogeneity issue as well as serial correlation problems. All right, so if you want to know how to estimate the unit root test and co-integration test and all of those, you can watch my previous videos that I made on unit root test and ECM, so that I can see how to estimate unit, so that I can see how you can be able to estimate for your unit root test and co-integration test and all of those. Okay, so essentially this is how to conduct dynamic ordinary least square estimation using EViews. Okay, if you found this video interesting, kindly share it with people that might be in need of it, and I believe it has been helpful to you also. Okay, thank you for watching and visiting my channel.